So we want to look at how we can use the expanded form of the standard form of a quadratic function to find the minimum or the maximum value of a quadratic function. In our previous lesson, we were able to come out with the standard form of a quadratic function. And we said that the standard form of a quadratic function is giving us where k is the minimum or maximum value, and the value of x, where the minimum or the maximum value occurs, is giving us x minus h is equal to 0. So how do we use the expanded form of this standard form to find the minimum or the maximum value of a quadratic function? So we have an example. Let's go through it. So we want to find the minimum value of this function and the value of x where it occurs. So what we are going to do here is to equate the standard form to the quadratic function given. Now once we have this, what we are going to do is to expand this part. So we are going to expand this. The expanded form of x minus h all squared is going to be s squared minus 2sh plus h squared. Then we have plus k is equal to, now let's expand the bracket, a s squared minus 2axh plus a h squared plus k is equal to the whole of this. Now once we have what we are going to do is to compare the terms on the left hand side and then the terms on the right hand side. This term is equal to this term, so we are going to equate them. So we are going to have a s squared is equal to what? S squared. We can also see that this will be equal to that, so we are going to equate them. Minus 2axh is equal to 2x, and then lastly we compare the rest. A squared plus k is equal to minus 3. Now let's solve for the variable a, h, and then k. So from here we can see that this will cancel this. We are left with what? A is equal to 1. From here also we can see that s will cancel this. We have minus 2ah is equal to 2. So we'll be left with minus ah is equal to 1. Already we said that our a is equal to 1, so we have minus 1h is equal to 1. So we can say that our h is equal to minus 1. Now that we have this, let's move on to this very part. So we said that the whole of this a h squared plus k is equal to what? Minus 3. We have already found the value for a and then h. So our a is 1. So we have 1 multiplying h minus 1 all squared plus k is equal to minus 3. So you can say that 1 plus k is equal to minus 3. Therefore, our k is equal to minus 4. Now that we have all of these variables, a, h, and k, we are going to substitute it in place of this standard form that we use, which is the same as this one. So we are going to have our f at x is going to be, our a is 1, so we have 1 x minus our h is minus 1, so we have minus 1 plus k. Our k is what? Minus 4. So therefore from here, okay, let's simplify this one. So we are going to have x plus 1 all squared minus what? 4. So once you have the standard form, we can see that the whole of this is our minimum value, and it occurs at x plus 1 is equal to 0. So you can see that our s is equal to minus 1. So therefore, the minimum value of this quadratic function is minus 4, and it occurs at s is equal to minus 1. As easy as that. So we want to find the minimum value of this very function and the value of x where it occurs using the expanded form of the standard form. So we are going to create the standard form to this quadratic function. We are going to equate it to 3x squared minus 2x plus 1. Now once we have we expand this part, we are going to have a is out. The expanded form of this is going to be x squared minus 2xh plus what? H squared. Then we have plus k is equal to 3x squared minus 2x plus 1. Now let's expand this part also. So this time this we are going to get a x squared. We have minus 2axh plus a h squared. Then we have plus k is equal to the whole of this. Now once we have this, we are going to compare the terms on the left hand side and then the terms on the right hand side. So you can see that this is equal to that a x squared is equal to what? 3x squared. You can also see that this is equal to minus 2x. So we are going to have minus 2axh is equal to minus 2x. And lastly, we are going to create this and then the last one. So we have a squared plus k is equal to positive 1. So let's find the value of the variables. So from here, we can see that this x squared will cancel this x squared. We have our a is equal to 3. We can also see that this will cancel this. Minus 2 cancel minus 2. We are left with what? AH is equal to 1. Our a is 3, so we have 3h is equal to 1. So from here, our h is equal to 1 all over 3. Now from here, our h is what? 1 over 3. Our a is what? 3. So we have 3 multiplying 1 all over 3, all square plus k is equal to 1. So we have 3, we have 1 all over what? 9 plus k is equal to 1. So this will cancel this. We have 1 all over 3 plus k is equal to what? 1. We are looking for k, so we have our k to be equal to 1 minus 1 all over 3. So therefore, we can say that our k is equal to 2 all over 3. Now, once you have the value of these variables, we are going to substitute it into the standard form of the quadratic function. So we have our a x minus h all squared plus what? K. Our a is what? 3. X minus our h is what? H is 1 over 3. And then our k is what? 2 all over 3. So this is the standard form of the quadratic function. So from here we can say that our minimum value is what? 2 over 3. And it occurs at x minus 1 over 3 is equal to 0. So we have our x is equal to 1 over 3. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.